Good afternoon. Welcome to today's TASA webinar, Slip and Fall Accident Investigations, an Engineering Perspective. Walking accidents will injure millions of people each year, and thousands will die. Slip, trip, and loss of balance accidents are the second highest cause of accidental death among the elderly. The effects of these accidents can be devastating, resulting in extreme changes in lifestyle and monetary losses to the victim. Most of these accidents are the outcome of some defect of a premise arising from the lack of proper maintenance. Walking is an extremely complex task when one tries to understand the mechanism of these accidents. Walking, in reality, is the process of locomotion in which the human body moves along, supported first by one leg, then by two, and finally by the second leg. The accidents occur at the time when the body is supported by only one leg due to dynamic effects and the required reaction at the contact point with the ground. During this program, our presenters will cover the following: the mechanics of walking, gait, and balance, the difference between slip, trip, and loss of balance, understanding the coefficient of friction, effects of the changes in friction, grade, and contamination, measuring friction, national standards of care, walking area maintenance, environmental issues, falling in different environments, public facility issues, conducting an investigation, and useful evidence to build or defend such cases. The presenters for today's program are Dr. Carl Berkowitz and Dr. Oren Masory. Dr. Berkowitz has 48 years of transportation and traffic engineering experience. He has served as a litigation consultant and held various positions in industry, government, and higher education. He has extensive experience in planning, design, safety, security, construction, maintenance, operations, and management. Dr. Berkowitz holds a bachelor's degree in civil engineering and an MBA in industrial management from the City College of New York, and a master's in science and in transportation planning and a PhD in transportation planning and engineering from NYU Poly. In addition to his work involving pedestrians in virtually every form of transportation and its safety, including aviation and maritime, Dr. Berkowitz has written numerous reports and articles for major publications, chaired task forces, appeared on national television and radio, and made many scholarly presentations worldwide. He holds memberships in many transportation professional associations. Dr. Berkowitz's areas of expertise include accident analysis and studies, slips, trips, missteps, and falls, pedestrian and passengers, perception reaction capabilities, intermodal transportations, bicycles, buses, school buses, subway, ferry, cruise ships, commuter, and intercity rail, escalators, elevator, and moving walkways, among others. Dr. Oren Masory holds a BS, MS, and PhD in mechanical engineering from the Technion, Israel Institute of Technology. Currently, he is a professor in the Department of Ocean and Mechanical Engineering at Florida Atlantic University, which is located in Boca Raton, Florida. He has over 30 years of mechanical engineering experience, has served as a litigation and engineering consultant, and held positions in industry as well. His research interests include robotics, automation, machine tool controls, assistive technology, and accident reconstruction. Oren is an expert on vehicular accident reconstruction, low-speed rear-end collisions, slip, trips, and falls, pedestrian accidents, machinery, product liability, building and safety codes, speed and distance analysis. Oren has written numerous reports and articles for major publications on the above topics, and he holds memberships in ASTM and SAE. The presenters have asked that we take questions throughout today's presentation. If you have a question, please use the chat or Q&A feature located on the right-hand side of the screen to submit your question to the presenters. We encourage all attendees to submit questions. Tomorrow morning, I will send out an email with a link to the archived recording of this program. We do ask that you take time to fill out the survey that will appear on your screen after today's program is over. Now I invite you to sit back, relax, and enjoy. I'm going to turn the presentation over to our distinguished guest. First, we'll hear from Dr. Carl Berkowitz. Carl, the program is now all yours.
Thank you very much for that wonderful introduction. We appreciate it very much. As we get started, it would be good to define what we're going to be talking about. And the areas we're going to be talking about are slip, trip, imbalance, and fall. Slip being the interaction between the footwear and the walking surface. Trip being the engagement with an object or an irregular change in height along a walking trajectory. That's a change in grade. Imbalance being the stepping on an unstable surface. Examples like loose tile, anything that on the walking surface that can cause instability. And a fall is the event from the result of the slip, trip, and imbalance that causes an individual to end up on the floor or the ground. So that's what we're going to talk about today, and I hope you enjoy the presentation. The statistics in this area are mind-boggling. Thousands of people are injured each year in slip, trips, imbalances, and the resultant falls. And the costs into the billions and billions of dollars, not only in litigation costs, but in medical costs, in damages, injuries, and all the various gamuts related to these type of injuries. If we break down the causes of slips and falls, we can break them down to those involving the floor, and you can see that's the predominant of those types of accidents. Footwear being second. There is a lot of incidents of fraud, which is third. Then we have hazard identification, and a very tiny area is improper training, which barely shows up in the graph. The factors that involve these types of accidents, of course, the person involved and the type of person that person is, the age, experience, health, the activity they're performing at the time, the environmental factors that might be out there, such as weather conditions, etc., temperature and lighting, and of course the walking surface. Falls, as we all know, are very commonplace. Individuals from infants to elderly are involved in these type of accidents, and in most cases, fortunately, the outcome is nothing more than an embarrassment. And when injuries occur, they can be far-reaching and debilitating and have significant consequences. The types of things we're talking about, the fall problem, can occur on a level surface, on a slope surface, on steps, on stairs, from heights, and these are some of the primary different places where these types of accidents can occur. And of course, these falls involve a loss of balance due to some reason which results in the person falling to the ground or another level, which can also be a very serious matter, falling from heights. We can break the falls down into various categories. First, circumstances. That's whether it's on a level surface, on a slope surface, on stairs, from a height. We could also categorize it based upon the age of the person, their health. Also, thirdly, we can then break it down by location, such as hotel, terminal, parking area, sidewalk, etc. The factors that come into play in terms of which result in a fall is something that we call gait. That's the walking pace of the individual, and that's being disrupted can cause a loss of balance, and depending on the individual's stature, strength, and vision and behavior, a fall can be the end result. This is a pictograph of a typical walking, and the interesting thing about walking is a process of imbalance. We go from imbalance to imbalance. Every time we take a step and we lift our foot, we're in an imbalanced position. Every time we put our foot down and pick up the other foot, we're in imbalance. The only time we're in balance and not out of balance is when both feet are firmly planted on the terra firma. So this is the sequence of the stance through the swing phase of typical walking. And the gate cycle is from the first foot being planted down in front of you to the rear foot coming and being planted. And that the distance between the first foot and the second foot, that space in between, those motions in between, is what we refer to as the gate. Of course, there is a dynamics in the slip and fall. The front foot, for example, hits a slippery surface or an uneven surface or something, and if it's a slippery surface, the tendency is to lose balance and to fall back on one's backside. The types of falls that we're talking about are influenced by a person's health, whether they're fatigued or in good shape. Are they on medication? Are they under the influence of alcohol or drugs? Is the environment such that there's weather conditions to be concerned with, such as snow, a wet surface, and what type of activity are they taking place? Is it a recreation activity, a work activity, etc.? Again, fall outcomes. If we fall on a level surface, the likelihood is that a lower and upper limb will result in perhaps fractures, sprains, back or head injuries. Falls from height can often be serious and can generate some severe injuries in terms of the distance that the person falls. If it's a short distance, it's one thing. If it's a significant distance, it could be catastrophic.
Okay, Oren, I believe it's now your part of the presentation.
Also, there's an individual can't hear.
Do you hear me?
There's a Douglas.
If you could speak up a little, Oren.
You don't hear me?
No, I hear you.
Yeah.
One of the individuals said they can't hear.
Well, tell me if you hear me. That's what's important.
Yeah, if you could just speak a little closer to the speaker or put the receiver up to your mouth, that would be great. You're a little faint.
Hello, do you hear me now?
Loud and clear.
Okay, so that's what I do. Well, I'm repeating here the sleep factors that we already mentioned. I just want to go directly to the meat and the bones. First of all, what's the definition of a friction? This is the interaction between two surfaces which are in contact, obviously, while moving one relative to the other. So we are looking at the foot and you're looking at, let's say, the walkway. They are in contact. There are normal forces between the two. And obviously, when the slip occurs, there's a relative motion between the two surfaces. Some historical perspective, believe it or not, Leonardo da Vinci was the first one to start to concern with friction. And what you see here at the bottom, it's like a simple device where you pull to the left and you sense what is the resistance to the pulling. If you look at this device, this is the block, this is the surface he's examining, and there's a pulley right here, and he put some weights here, and he tried to figure out what is the weight he has to put here in order to cause motion. The next one was a little bit more systematic. His name is Mr. Augustin Coulomb, and he was investigating dry friction, which means there is no liquid, no lubricant between the surfaces. And many textbooks, when you talk about Coulomb friction, eventually you refer to this particular person and obviously to a dry friction or dry surfaces. Okay, to understand this, we have to imagine a little experiment that you see here. What we have here, we have a surface and we have a block. These are two wheels, which means there is no friction between this surface and the wheels. This surface is connected to this wall with some kind of a meter which measures the force, and I'm going to pull the block to the right. At the beginning, as I'm pulling this, there is enough friction between the block and the red surface, and as a result, the whole cart will move to the right, and the force I'm applying here is going to be measured in this particular dial. And that's what you see on the graph. I'm pulling with F. The friction force is still high enough here, so nothing is moving. And I continue to do this until a point that the force that I'm applying here is exceeds the value of the friction force between this block and this surface here. And as a result, the block starts to move or to slide on top of this surface. At this particular point, the force, the friction force drops to a certain level, and the block will continue to move, but the resistance to the motion will be less, which means what we see here is there is a resistance to the motion relative, and it's called kinematic coefficient of friction. But what we are interested is at this particular point where the motion starts. This is called impending motion, and this point defines the static coefficient of friction. So we are talking about a very particular point in the process because this is the point where the person starts to slip, or vice versa. This is the force that the surface has to provide in order to, or the maximum force the surface can provide that might prevent the slip. So by definition, again, this is the normal force between the surface and the block. This is the weight of the block, this is the friction force, and this is the force that we are pulling. And the coefficient of friction is defined by the ratio between the friction force and the normal force. This is mu(s). The S stands for static. And one of the mistakes that many people and many students and some even experts are making is they always remember that the coefficient of friction is a ratio between two things, and therefore they say that mu(s) has to be between 0 and 1, which is obviously absolutely positively wrong. The coefficient of friction can have values above 1. It can be 1 and 2 or 3 and 5, depends on the material. So it happens to me at least a few times that I had to deal with an expert who thought that the maximum value is 1 because of this ratio that he remembered. Second thing we have to remember that some of the surfaces that we are walking on are a little bit sloped, and you ask yourself what does it mean to us. One thing we have to remember that the definition of the coefficient of friction remains the same, which means there's the ratio between the friction force and the normal. And when you work this out, you find out that this ratio down here is equal to the static coefficient of friction that we found a minute ago, minus the tangent of this angle, which means that the apparent coefficient of friction is being reduced by this number. So if we take a standard ramp, this is a standard ramp where the gradient is 1 to 20, you find out that the apparent coefficient of friction of the ramp is dropped by 0.05. This 0.05 might be quite critical to us because if we consider a threshold of between slippery condition and non-slippery condition as 0.5, and you find 0.5, you have to claim, eventually say, listen, because of the slope, what the person eventually experiences a coefficient of friction of 0.45, which is below the threshold, and therefore the conditions are slippery.
Oren, just one second here. We have a question from Edwin, who asked, is it not true that we could express this as friction, or F equals the amount of force divided by the weight of the object?
Not necessarily. It's divided by the normal force between the surface and the object. For example, here you see this is the weight of the person, if you want, this is the normal force. The normal force is always normal to the surface, and therefore the coefficient of friction is Fc divided by N. If the surface, I'll go back here, if the surface is horizontal, it happens that the normal force equals to the weight of the person. This is the W. But in any other case, this is not true. I hope I answered it. Okay.
Thank you for the clarification. I don't see any other questions, so why don't we
continue.
We have a follow-up here from Edwin, who asks, what is normal force?
The normal force is a force which is normal to the surface. You have a surface, and the surface doesn't have to be flat, but at any point you can always have a tangent to the surface, and the normal force is the direction which is perpendicular to this tangent.
Okay. Thank you so much,
okay.
Oren.
Okay, so from now, I'm going to go through some particular cases which have to be considered. One is what happens when you have a change in coefficient of friction. This happens many, many times. In particular, here in Florida, I'll show you some examples, but in the north is even worse. Take, for example, that you are walking from home and you go out. So at home you have a carpet or any other surface which have high coefficient of friction, and outside you have a low coefficient of friction because of snow and ice. And as you walk from high to low coefficient of friction, there is a good possibility that you are going to slip. And the reason is that it takes our brain about 3-4 steps to adjust the gait to, this is a spelling mistake here, I'm sorry, to adjust our gait to the new coefficient of friction. So you can see a lot of accidents in the first step that a person takes outside of the house. An example in Florida is what you see in this picture. Here is a bare concrete, where the water is being absorbed, after the rain. And here, just next to it, is a painted surface, and you can see half an hour after the rain, you still have some little puddles here. And the guy steps from this point to this point, which means at this surface there's very high coefficient of friction, and he puts his foot right here, and this is low coefficient of friction, and he has the risk of eventually slipping right there. And this happens around swimming pools and some other walkways where, some of the administration wanted to make it beautiful, so they painted it, and now you have surface which does not absorb water, another surface which does, and there's a big difference between the coefficient of frictions. Another thing is contamination. Again, this is a picture I took from one of the cases, and here comes the rain, and there's a little bit of mud. And if you look at this, this is like sand more than anything else. And you run the experiment here, and you find out that the sand particles eventually reducing the coefficient of friction by dramatically, more than 50%. And the reason is that they are behaving like small balls. So eventually, rather than sliding on the surface, you are rolling on the particles that like you are rolling on marbles. They are very, very tiny marbles. So this can affect or cause some accidents. This is maybe too busy of a slide, but what you see on the left here is different treatment of the surface. What you see here is different loads and different pulling velocities. And the most important thing is to see that there are variations in some of the cases. Sometimes the variations are very small. You can see 0.3 is all the time. But in some other cases, because of different treatment of the surface, the coefficient of friction can drop from 0.8 to 0.5. So it's not that you can go to a table and find out a coefficient of friction because somebody ran some experiments and use it in your analysis. You have to be there and eventually take measurements of the surface that you are dealing with. I think this is the main message of this crowded slide. Okay, so you never use this. I mean, you always have to go and measure. One thing is important is to see the difference between dry and wet. You can see here it drops from, even though it's different materials, but it dropped from 0.57 to 0.11, which is very, very dramatic here. Chemical interactions. I'm sure you went, maybe if somebody had a chance to go to a clean room facility, and they treat the surface, so particles and dirt, whatever, will stick to the surface. So when you walk there, you eventually walk on some kind of a gluey surface, and the coefficient of friction is very, very, very high. So depends if there is any kind of a chemical interaction, that's what I call it, between the footwear and the surface, you might achieve very high coefficient of friction. The minimum requirements at this point, the minimum requirements is to have a coefficient of friction of 0.5. If you have higher than this is like a threshold. A higher value is considered safe. Below this is considered unsafe. But it doesn't mean that if you have a coefficient of friction of 0.7, you cannot slip, or vice versa. You can walk on the coefficient of friction of 0.3 and still maintain your balance. One thing is the American with Disability Administration is trying to push is to increase this value to 0.6, at least for those surfaces that handicapped people are using.
Oren, we have a quick question about a point
Yes.
you just went over.
Yes.
Do you mind addressing it right now?
Yes.
From Tom, who asked, how do you evaluate the coefficient of friction when the contaminant has been removed? What is your method for determining?
Yeah. Well, I have eventually two answers to this. One, and this is very unfortunate, you want to run the test as soon as possible. The unfortunate is that in many cases of personal injury lawsuits, the case might come, maybe a few months or sometime even later. So this causes a difficulty. The best you can do eventually is to measure the coefficient of friction at the time that you were asked to. I mean, because you never know what was the surface before, unless you have some kind of documentation. For example, if the surface is being cleaned 3 times a day, and this was 5 minutes after the cleaning, okay, maybe you can coordinate this at that time. If the surface was treated every 3 months with some kind of wax, and the accident was like 2 weeks after the application, you try to schedule this to a similar time, with the idea that the traffic and the wear of the treatment is similar. But otherwise, the best thing to do is to go to the site, 2 minutes after the accident, which never happens.
Okay, and we have a follow-up question from Faith, who asked, would the safe coefficient change based on the expected population? For example, would a hospital or nursing home be expected to have a higher standard coefficient? If so, can you point her in the direction of those standards?
No. At this point, there's one number, which is 0.5, which I have to tell you the truth, I have hard time to justify. I don't really know how this came around. But I don't think there is one started for hospital and one started for supermarket and one for your home. It's the same standard.
Okay, great. I don't see any other questions, so why don't we continue on with the presentation, Oren?
Okay. Okay, so we talk about standards. As I said before, there are many organizations taking care of it, like OSHA, ADA, ASTM is having standards how to perform the experiments. The National Fire Protection Association, state and local authorities. But most of the time you go to ASTM to find how to carry out the investigation, and either you go to OSHA or to the state to figure out what the standards. That's typical. So let's talk a little bit about the measurement devices, because there are so many of them around, and it's very important to know what to use and what to ask. So the simple one is ASTM 1028, and this is a pull test, which is eventually carrying out the definition, by definition, what is μs. This is the same experiment that I was mentioning a few minutes ago, that here it is, you are pulling the weight with a certain force until it starts to move, you know what's the weight, and you find out what is μs by dividing F divided by W. Okay, so this is the simplest one. Now, it sounds simple, but it's not simple. And this is most of the attorneys that I work with, they have to know, or you guys have to know, that there is a calibration process, which means, yes, you went out and you measured the coefficient of friction. But if you look at this device here, these are the weights that I'm using. This is the force gauge that I'm using. But below this little plate, there is a neolite, 3 inches by 3 inches neolite, and that's the surface it's like the bottom of the shoe, which is in contact with the walking surface. You have to run a similar experiment on calibrated plate. This plate that you see here, this is a very special tile that you have to purchase from some lab, and the lab come and tell you the coefficient of friction of this tile was measured in some on some very, very accurate devices. And once you finish your experiment, you have to calibrate your system using this surface. With this calibration, you eventually make corrections to the coefficient of friction that you found on the site. If you don't do it, your measurements are eventually not valid. This is one thing you have to do. The second thing you have to do is whatever force gauge that you are using, you have to calibrate the gauge immediately after or immediately before the test, so your measurements will be correct. Whatever device you have, there's always a bias, there's always drifts, there's plenty of problems. So two things, you have to calibrate your device, and you have to calibrate this pad that you are using there on what we call a standard surface that you have to purchase someplace. There are many different standards by ASTM. These are some of them. They are talking about different methods, and I'm going to just show a few of them. This is called British Pendulum Tester. It's more expensive, and sometimes it's not really portable. Some people are using it. This is called James machine, and you can see here, this is the surface, and this is the, right here, this is the sample that he's trying to test. This is a nice machine, but obviously it's good only for a lab kind of environment. This is the Brand Grabber Mark II device. It's portable, and you can see you can measure with it the coefficient of friction on tiles, on roads, and this is acceptable by ASTM. This is something that many people don't know, and I was burnt with this a little bit. There is one machine which is called English XL. There was a standard, ASTM 16379, but we ran some experiments with this device, and it found that it has a very poor repeatability, and therefore the standard was dismissed. So it's very impressive device. If you go to court and the guy comes with it and show this to the jury, and it makes noises and all this kind of things, very, very impressive. The fact is that this machine cannot be used for measurements. And then there are some others. I mean, the problem is so severe that many people are trying to come with some devices, some very, very simple ones, some more complicated. Depends what the expert want to use. Okay, some other difficulties. One is when you are trying to measure the coefficient of friction when in wet conditions, in particular when it comes to just water rather than oil or any other liquids. There's a problem which is called stiction. Stiction is a phenomenon when you have two surfaces under pressure and there's a very, very thin layer of liquid in between. Think about two layers, and what happens is there's a stiction between two layers of fluid. One is attached to the surface, one is attached to, let's say, to the sample, and you find to your surprise that the coefficient of friction you measured in wet condition is higher than the one you measure in dry condition, which is against to any intuition you have. And the result of this, or the way you fix it, and eventually with this calibration tile that I showed before. There are some local factors, some irregularities on the surface at the site of where the accident happened. The surface was treated. That's what we talked about a second ago. And the most difficult thing is you run a few experiments. Let's say this is a pull test, and you run 5 or 6 or 10. There is no standard to tell you how to analyze this statistically. Eventually, the standard ASTM, they ask for 4 pulls in 4 directions, which at the best is 12 measurements. If it's 12 measurements, the meaning of mean or average doesn't mean very much unless you make a correction, like using a student distribution. But the standard does not force you to do anything. So somebody can represent this as a normal distribution. Some other represent as a t-distribution. So you have to know. You have to ask how many measurements you took. You took 6. 6 measurements is a very low number. You cannot use normal distribution anymore. Have you made the correction using student distribution? And you have to be a little bit more involved in order to get results which are more reliable. Okay, we'll switch to TRAPE. The TRAPE is, first of all, what's important is the height. Yes.
Oren, before you start, we have a couple questions here related to the last section. Can we go over those very quickly?
Sure, absolutely.
Okay. Tom asked, what do you mean the English XL was dismissed? Has it been, the standard's been removed by ASTM, correct?
Yes. That's what it means. Dismissed, it means that it's not accepted anymore.
We have a question here from Alan who asks, how effective are photographs taken soon after a fall in determining the coefficient of friction?
Not very much, nothing. Coefficient of friction, it's not something you can see. Unless, the guy is walking on a glass and this is a very rough surface. But otherwise, you can see even a shiny surface, it still doesn't mean that the coefficient of friction is low.
Okay, and
photograph will not help you.
Oh, sorry. And a question here from Lewis who asks, is it possible to measure the friction coefficient for wheelchair tire?
Yes, of course. What you have to do is you have to lock the wheels and then eventually pull the chair on the surface. Just the same as you measure the drag factor, we call it, between the tires of a car and a road.
Okay, I don't see any other questions, so why don't we continue on with the presentation?
Okay, so, I'm sorry. So we are talking about the trip. The trip is, there are a few factors affecting the trip. One is obviously what's the height of the obstacle, visibility, and the color of the obstacle. So what's the trip mechanism? At the time of the impact between the foot and this little obstacle, the body has linear momentum. Linear momentum, it means that we do have a velocity. So here it is. There's an object in velocity, and you are trying to interrupt the velocity, the motion. So think about a case like a bike. Forget about human, a bike, and you drive in very high speed in bike, and then you impacted, let's say, a curb or a rock. There's a good chance that you are going to flip over. So this is just the same as we are. Obviously, we are supporting by 1 foot, and because of the impact, you can lose your balance because of that. And second is the center of gravity as we move is in front of you. So once you interrupt the motion, the center of gravity will cause you to fall down. And this is just little examples. Here you see that this surface and this surface, the difference is about 1 inch or so. And as a result, the tip of the shoes here eventually stuck here. And if you manage to overcome this here, you might stuck it here. Or in the worst case, in high heels, you can insert the heel in between the two surfaces here and trip. Many other places that this might happen, you have a breakage, in particular in corners and edges of a concrete kind of walkways. Sometimes you have a real busy things on the walkway, like maybe intersection between some of the slabs. Sometimes you have water drainage. Who knows? And in this case, there's a difference between this surface and this surface, between this surface and this surface. So you come to here, there's a good chance that because of the irregularity that you might trip. In many cases, we have this big step between here and here when you have two totally different surfaces. So you can see this is the road, this is the walkway on the road, and this is the pavement. And the two are made of two different material. This sinks more into the sand, let's say, and this is less. And therefore, between this point and this point, it's almost 1 inch. And then you have, nature takes course, like the roots of this tree or the roots of this tree. In Florida, it's very common. The trees are growing very, very quickly because water and sun. And you can see here, there's you can trip at this corner, in particular if you are, text messaging. This is a little comment here. What's the requirements? Most of the local authorities and also ASTM and some others, they allow maximum deviation between two surfaces of 1/4 inch. And the reason for this is if you look at your shoe, the tip of your shoe is about 1/4 inch above the surface. So when you swing here, there's a good chance that the tip of your shoes will not hit this edge, but will come over it. Standards are the same places. These places who worry about slipping is worrying about tripping. There's no question about it. And the last issue is what is imbalance. Imbalance is stepping on unstable surface. For example, if you look at this tile here, if you step here, it will tilt and to here, and two things will happen. First of all, you won't get your stability, and second, because of the angle, maybe you lose some of the coefficient of friction on this particular tile. And the same here. All of these tiles are loose. You are stepping on them, and you might lose your balance. So I made a little kind of a model. What does it mean? And this is the tile. It means you push here, the tile will rotate in this direction. Now you have, 5 to 10 degrees slope. If we go back to the definition of coefficient of friction or the apparent coefficient of friction, it reduces the grip or reduce the apparent coefficient of friction. Okay, that's what I was eventually mentioning here. Okay, I think Carl, this is your turn.
I'll here. What we want to tell you about is there's a number of engineering principles that come into play, and the first thing is that we need to understand what's causing the problem, and that's understanding the hazard. And if we understand the hazard, we can begin to deal with it. And the next thing, of course, is to eliminate it. And if we can eliminate it, to allow people to know that are using the facility that has the hazard, to warn them of the hazard. And by doing these kinds of things, we minimize the risk to the individual to the hazard. And in that way, we reduce the possibilities of an accident resulting from a slip, trip, or fall. And the best practices, really, it should be the national standard of care, and that's the standards that have been developed by the American Disabilities Act and promulgated through the architectural boards and the U.S. Access Board, which has developed standards for each aspect of the activities of walking. And these standards, if followed, will greatly reduce the types of accidents we've been discussing. If we wanted to pick what is the best practice, and of course, the best practice is to prevent an accident is to remove a hazard. And we can easily improve any situation by quickly eliminating the hazards. Unfortunately, the time where a hazard is identified and action is taken usually requires somebody being injured before some action is taken on a particular hazard. But there should be an effort on the part of engineers and a part of system engineers and safety engineers and people involved with the safety of pedestrians to try to identify hazards before they cause accidents and not to wait until the accident occurs to take action. And of course, we mentioned many of these previously, the various standards and codes. In addition to the ones that we mentioned, there are numbers that are of standards that are developed by the professional societies, such as the American Society of Civil Engineers, the American Society of Mechanical Engineers, Institute of Electrical Engineers. There's a lot of international code bodies. There's the Underwriters Laboratory, and et cetera, that are promulgating guidelines, standards, and codes. There are many different environments that we can encounter that cause slip, trips, and falls. The walking surface, the weather conditions. A lot of accidents occur in parking areas where we tend not to pay as much attention to hazards because of the amount of activity and the size of facilities. We tend to overlook changes in level, problems at entrances and exits. We tend to take for granted that elevators and escalators are safe at all times, and there are always potentials. Anything that's mechanical can result in some kind of problem over time. We always got to be aware of elevated surfaces, changes of surfaces, places where there's unprotected changes in grade, where there are no railings, where such as in playground areas and work areas, on public properties. We got to be careful, especially when we're dealing with seniors and residents, if the residence isn't properly protected to prevent them from falling. Of course, construction sites where sometimes the housekeeping is not up to the standards that we would hope for. And of course, whenever we're dealing with elderly and disabled, there are special situations and special needs and considerations. The first line of activity is really the pathway, and this is where many of the accidents occur. and that's the walking area basically. And it's important to take into consideration the floor materials. You may not always want to have the most beautiful, because the most beautiful might not be the safest. So it's important to select the right material and the right cleaning procedures, because a slippery surface, a surface that's been identified as slippery through specific cleaning processes and treatments, can be made safer, and that's through regular maintenance. We also want to ensure that any surface we're dealing with is free of obstructions, there's no sudden changes of grade, and that we adhere to at least the minimum standard for friction of 0.5. Oren?
Okay. This is a very special topic, slip and trip on stairs. Few things before we start. First of all, most of the accidents on stairs happens when you step down the stairs, and the reason is that when you up and you go down, you eventually have to release energy in a quantum manner. What does it mean? It means that each time you go from step one to the lower step, you are reducing your potential energy, and you have to contain it and to stop it. And this causes difficulty. Okay. So one of the difficulties that we see right here is that you need to have a little bit of horizontal support when you are putting your feet on the next stair down. If this particular surface here is very, very smooth or have a very low coefficient of friction, this lateral support is not provided, and eventually you can slip in this direction. Second, as you move down here, also you have a velocity in this direction, and therefore, just the same as tripping, you have to contain this velocity. You have a momentum, and the momentum is being stopped stair by stair by the force or the interaction between this feet or this shoe and this particular surface. So this is one. The trip, another trip is when you go up, and just the same as we mentioned with the coefficient of friction, if you have a change in the coefficient of friction, there is a need for 3-4 steps on a new surface in order to the brain to adjust for the new gate. So when you go on stairs, if the rise of the stair is not the same, let's assume the first 3-4 are the same. As you step up, the gate you maintain a certain gate. If suddenly there is one stair which is higher than the next one, there is a good there is a good chance that you are going to hit the stair rather than to put your foot on the top of it. And the reason is, there are many reasons. One is because of establishing a certain gate, but second, we are trying to move our feet at what we call minimum energy. You don't want to raise your feet, 5 inches above the surface of the stair. You are losing energy. You want to put your feet, or to raise your feet maybe a quarter an inch, half an inch above the surface. You move the feet forward, and then you put it on the surface. So if you establish this gate, and then you come to a higher one particular higher stair, there's a good chance that you are going to hit the tip of your foot with the riser and trip. This happens many times. The other thing which is important is to be able to distinguish between the edges of the stairs. So if you look on the right, for example, you can see that this pattern make it very, very difficult to find out where is the edge of the stair. For example, here is an edge right here, which is very difficult to see. If you have a very rich pattern, when you are looking down, you see this pattern and this pattern continuing each other, and you don't see, or you cannot distinguish there is another stair here. And the same thing with patterns like this. So you have to make sure that there is a way to see the edge or the nose of the stair. This happens a lot of time when you have wooden stair, because you have the planks parallel to the stairs. So you have one plank here, another here, another here. When you are sitting here on the top, you don't know if this plank belongs to this surface or belongs to this surface, and you can miss the stair. These are just definition what the stair is. There's the noise, there's the pitch, there's the rise. This is given. This is usually the standard. This is almost every building code. The riser, which is the height, is about 7 inches. Give and take, 11 inches is the depth. The width is the minimum 20 inches, so one wide person can walk. 80 inches the clearance to the ceiling, and some other details here. Okay, the last thing is some information about aging. As we're getting old, we are less aware of things and less alert, and this might cause skipping some of the warnings of seeing the edge of something or to see an obstacle, this kind of thing. It's amazing that 1 out of 3 seniors fall at least one time every year. Injury is very, very serious. At least here in Florida, I'm aware of it. Old people fall, they break their hips, they break a leg or something, and this is a major trauma. I mean, some of them unfortunately cannot even recover. Either they have to use a wheelchair, or in some other cases it's even worse. Most of the accidents is at the home, which might sound very strange because you're supposed to be familiar with the environment. But on the other hand, if you think about it, you are so familiar with the environment, so you feel very, very confident, and therefore you don't take all the precautions that you have to take. This is the same with another example is, let's say, car accidents. Most of the car accidents happen very close to your house. Why? Because you know the road, you know the environment, you know the stop signs, and you feel by far more relaxed. And as a result of this, you are missing something. And then you have if the guy has problem with vision and hearing, obviously this will cause a problem. This is just giving you some statistics. You can see that the fall is 66% of all injuries with elderly people. And a major, more than 50%, is in their home. Some maybe 25 at residential institution, and some others. It's amazing that the commercial areas are relatively safe if you think about it, because they take care of it. Okay, and these are also quite interesting to see. When I saw this the first time, I was a little bit surprised to see that only 9% of the accidents are in the bathroom. I thought that you go to the bathroom, you go from the tub to the floor. First of all, you need a little bit of maneuvering. Second, the floor is wet. But it's only 99% of the accidents, to my surprise. And in those places where you expect less activities, like bedroom and living room, you have the majority of the accidents. That's what happened with where the location of the accidents. Obviously, legs and hips, this is the major thing. Arms, if you try to protect yourself. Head is less, and and this is a study that I found, like 1,600 people, and you see where the accidents. The majority stairs and steps. Then you have flooring. This is still a case of slip and fall. And then you have other surfaces. This is like concrete surfaces, another big thing. Bathrooms, another surface. Rugs and carpets is a major problem. In particular, if you have an old building and the carpets have ripples, ripples behave just the same as any other obstacle, and you less expect this because you have a carpet. It has a pattern. It's sometimes very difficult to see the ripple, and you hit the ripple, and you might obviously trip. And the last thing is illumination. You want to have a good illumination. Some of the problems are that once you have illumination, you are causing some shades, and the shade can mislead. You might think that this is a surface, but it's not a surface, etc. Some of the surfaces are glaring, so you cannot really distinguish between different either different surfaces or obstacles because you are eventually blinding. And there are some standards which tell you here what kind of contrast or what is the minimum illumination that you need. The illumination is measured by foot candle or by some other units. If this happens, you have to go and measure to use some kind of a light meter and to measure the amount of light at the surface, or sometimes, let's say, 3 feet above the surface. A good example for this is parking lots. I saw a few accidents where people are tripping on the stop blocks, and they see, hey, we never saw it because the road was concrete, the block was concrete, the block was not painted, so it was very difficult to distinguish from a color point of view, and the illumination was very poor because, yes, there was light there, and just below this light pole there was a big tree, and you don't see anything. So you have to go there and eventually measure the amount of illumination at the site itself.
Thank you.
This is Carl.
Right. I see the time is running late, so I'll go very quickly because the slides that we're going to present to the end are pretty self-explanatory. Things to be concerned about are when you have a distraction, there should be some kind of warning to alert the person to the distraction, and that's a very important thing in terms of eliminating hazards in the first place. If there's a distraction, there should be a warning, and the warning should not be a distraction in itself. The things to consider in terms of floor are explained here, and they're pretty self-explanatory. Things such as slipperiness and impact of wear and tear on the surface. This is very self-explanatory. Workplace falls are not uncommon. We have the standards of OSHA that try to reduce this, but because of the activities and the constant interaction, workplace falls are more common than one would expect. And a lot of things are done to try to prevent that, and that's in terms of how the floors and the foot interface, that people wear proper footwear and there's proper equipment used, and that training is ongoing, and that management is always ensuring that employees are always kept up to date in the best safety practices for their particular environment. As Oren mentioned, some of the things in parking lots, this just repeats some of that. And I'm not going to go through that at this time. You can look at it yourself. Terminal facilities, we have all different kinds of terminal facilities, such as bus stops. Parking lots are considered terminal facilities. High-rise parking facilities, airport terminals, bus terminals, subway stations, railroad stations. All these kinds of factors are important in ensuring a safe passage for the individuals that are using those facilities. One of the areas that we take for granted, and every commercial facility, industrial facility has a truck loading dock, and there are various standards and guidelines, and one of the simplest of those guidelines, I'm sorry, we jumped ahead.
Carl, we have a couple questions in the queue here that I'd like to get to. Do you think we could just focus on the questions for the next couple minutes?
Sure.
We have a question for both of you here from Ronald, who asks, is there a certain standard for when you should have a handrail when the steps are of a certain slope at a public venue, for instance?
Yes. There's a standard for the handrail, for stairs, and also for ramps.
And the standard specifies design as well as height.
Yes, of course. I see some questions on the Q&A, and I tried to.
Yes, please do address them, Oren.
Okay, so I'll go for the first one. Well, I don't know what he meant by. Give me a second here. One question from Daniel says, are there scientific or engineering dynamics helpful in describing why walker might not see hazard, especially why he cannot see? But I don't know, because I forgot my glasses. Or his attention was in a different place. I don't know if there's an analysis to this.
Well, also you want everything that's a hazard should be conspicuous, and we talk about conspicuity. That it's visible.
Okay, and then there is a question: what is ASTM F13? ASTM is American Society of Testing and Material, and F13 is the committee who deals with walk surfaces, etc. These are the committee that established some of the standards that I was talking about. And
which, by the way,
go ahead. Okay, and then the question is English Excel is the same thing as tribometer? I have to make, the answer is yes. But when we talk about tribology, usually we are talking about wear of metals and this kind of thing. There are devices to measure the wear of metals, let's say during friction. The Excel is a device to measure coefficient of friction between walking surface and the material of your shoe, for example. Let me see one.
Okay, thank you. We're really kind of pressed for time here since it's 3:07, so I think it would be best if we kind of wrap things up. What do you guys think?
Yes, I think so. I think everything that is in the slide presentation is self-explanatory. We deal with such things as the information that you should collect, the investigation. We talk about how to conduct an investigation, statutory controls, some theories of liability, defending a case, and such things as what evidence is useful and how do you get it. And the most important thing for us is selecting an expert and how to go about doing that. And I think the attorneys that are listening will find all this information of interest, and it's really very self-explanatory. And since each of them are going to receive a copy of this presentation, they can look at it at their leisure. And we thank everybody for participating.
Definitely. And Carl and Oren, thank you for the time that you put into this presentation. It was comprehensive and contained a lot of very good information. For those who are still with us, if you'd like to speak to Dr. Berkowitz or Dr. Masory about a specific case or project, you can contact us here at TASA. Our number is 800-523-2319. As we mentioned, tomorrow morning I will send out a link to the archive recording of this program. The archive recording of this program, along with all of our other programs, can be found in our Knowledge Center, which is found on our website. You click or you visit tasanet.com and you click on the Knowledge Center tab, which is found on the top of the page. Our next webinar for legal professionals, Survey Research Methods, collecting and processing data, will take place on November 20th. And if you have any follow-up comments or questions, they help us to produce better programs. Please don't hesitate to send me an email or give me a call, and we do take all of those comments under consideration, and like I said, they help us to produce better programs. With that being said,
you can also send out a PowerPoint, is that correct, of the presentation?
Yeah, I will send out the PowerPoint presentation tomorrow as well. I apologize. That being said, I will end today's meeting. Thank you for spending a little over an hour with us.
Thank you.
Thank you.
Okay, Carl, bye.
Bye now.